Okay, so we're on question 9. Just about halfway through the paper. And again, doing individual questions is great, but please try and do the odd paper in its entirety now and again, just to get a feeling for what it's like to do the full paper, because it can be quite mentally stressful. You know, a good hour and a half of working away, and then the feeling of do I need to go back and check things, and worrying. It's worth just doing it again just to see how you get on. Okay. So yeah, halfway through. Let's keep going. Right, in this diagram. So this information is shown on the diagram. There's 75, there's 37, and there's 20. So just score all that out. Calculate the length of DC. Well, I'm just going to put an X in. So we just need to worry about this diagram. I'll draw a proper X in. This one that's not completely rubbish. There we go. Right. So when you see angles and lengths, you should instantly be thinking sine rule or cosine rule. Now, if it's the cosine rule, a good bet is you'll see three lengths. Okay, so if it's got three lengths, it can't be sine rule. Okay. If you've got two lengths and two angles, that's going to be our sine rule. Okay. Now we've got a length that we need to find. There's a length. There's an angle, and we just need to know this angle in here. And that's us got all the information. Okay. So A over sine A is equal to B over sine B. So in this equation, I'm going to just put in x for A. So I'm going to say x over sine of an angle we don't know yet is equal to 20 divided by sine of 37. So can we find this angle? Right? Why have they given us a 75? Well, they're making us work for it, aren't they? They're making us do an extra step to say that's 105 because that's going to be the 180 rule. Okay, so just a quick reminder, any angle on a straight line or any two angles will add up to 180. Okay, so these two angles here, they're going to add up to 180. Okay, these two angles here, they're going to add up to 180. Okay, anything on a straight line, 180. Double that, and you're going to get 360. Okay, which should just be a circle. Okay, so any angles in a circle are going to add up to 360. Okay, so all these angles in here, they would all add up to 360. Okay, so you get the 180 rule and the 360 rule. You've got your vertically opposite angles, so this angle is the same as this angle. You've got your Z angles, or alternate angles is the proper name. If you get two parallel lines, that angle is the same as that angle. You've got your F angles, your fangles, or the corresponding angles, proper name. So that's the same as that. And again, we need to have parallel lines. No parallel lines in this one, so we're not looking at F's and Z's. No vertically opposite. It's the 180 rule we're doing here. Okay, so we know that's 105. Now, if you didn't know that, have a guess. Okay, so we're given this in the worksheet. There wasn't much working for that. That's given to us, easy. We obviously need to know to use it. And like I said, if you've got three lengths, it's going to be cosine. If not, it'll be sine. Okay. We knew it was this as well because we've got two lengths and two angles, two lengths and two angles. Right. The next step is rearranging. So we want to make x the subject. So how do we make x the subject? Well, we want to move sine 105 up the way. So on this side it's dividing. To move it over, we do the opposite. We're going to be timesing. Okay. Now if you think about what we're actually doing there, is we're timesing both sides by sine 105. Okay. So because we times both sides by 105, sine 105, we're not actually changing the equation. Okay. It's like timesing this side by 2 and that side by 2. Doesn't matter, it would just cancel out. Okay. By timesing both sides by sine 105, it actually cancels out on this side and then appears on that side. So that's kind of the mechanics behind why we do that. But basically, you're just doing the opposite action. Okay. So sorry, sometimes I'll talk through and you'll be like, yeah, no, that mate, just crack on. Okay. I like to just try and chat a little bit now and again. Okay. So yeah, we've got sine 105 and sine 37. That's times 20. Okay. So yep, into the calculator. Okay, so that's going to give us 32x is equal to 32.1. What are our units? Centimeters. Okay. Now, do a quick sense check. Okay. Does that look sensible? I think it's probably not wrong. That's 20, so I could agree that would be about 30ish. It's definitely bigger than 20. If you're getting something smaller than 20, you made a mistake. If you're getting 50 or 60, I might think, I made a mistake. But yeah, I can look at that and say, yeah, that's sensible. I'm not saying they're drawn to scale, but they're usually drawn sensibly. So that's good. The only mistake people can make here is by having a calculator set to radians and not degrees. Okay, so again, get to know your calculator. It should say deg on the top left or top right. Okay, it says rad but in radians. So it would mean you'd have to convert these numbers into radians, right? Or obviously just change your calculator. It's the easiest one. All right. So yeah, nice easy question there. Your marking scheme. You're getting a mark for this first point here. You're getting a mark for rearranging, and then a mark for solving. Simple. Okay, vectors. In the diagram below, we've got AB and EA, and they're represented by vectors U and V. Okay, so I'm just going to highlight them. So there's U, and there's W. So U and W. Okay, cool. Now, they've drawn this diagram out, and I think we should just label up what they're telling us down here. So it's saying that ED is equal to 2AB. So where's ED? There's ED there. So this length along here is twice the is equal to 2 times AB. Okay, so that length there is 2U, isn't it? Because AB is equal to U, so it's going to be 2U. Simple. It's saying that EA, so EA, which is W, is equal to twice the length of CD. So it's going to be a half W. Okay. And again, actually, because I've shown this diagram, I think that makes it easier because you can visually see that. Oh yeah, well, 2 of these would make that. Okay. So that's a good place to start. So just get rid of that. Now we need to express BC in terms of U and W. So we need to express BC, this vector here, B to C. Now I can just kind of look at that and say, well, if this length AB is U, then I know that this length here is going to be U. Okay. If this height here is a half W, then I know this height down here is going to be a half W as well. Okay, but because W is pointing up, that's going to be a minus a half W. Okay. Yeah, I can kind of look at it and see that. Right? So you might look at that and say, well, that's obvious. It's U minus a half of W, because I know that W is pointing up the way, we're going down the way because we're going from B to C. So that's easy to me. Right, so just to draw out maybe a bit bigger. So we're saying B to C is going to be U that way minus a half W. Okay, so B to C is equal to U minus a half W. You could say that. What if you can't spot that though? You know, what if you're looking at that thinking, oh, I'm not sure, I'm not sure. Well, vectors, we always add them head to tail, don't we? Now, why don't we just go all the way around? We just go all the way around from B to C this way, because we know what all these vectors are. All right. So if we were to go all the way around from B to C, okay, we would go minus U, we'd go minus W, we'd go 2U, oops, so I'm going to 3, and then we go plus a half W. Okay, so that's going all the way around from B to C. So let's collect our terms. There's our U, and there's our U. So plus 2U minus U gives us U, just the same as we've got up there. And then we've got minus W plus a half W. So that's going to be minus a half W. Okay, so two ways of doing it. Sometimes you can just look at it and just tell. Okay, I think because of the way they've drawn that, it's not as obvious on there as what some other examples are. So you could do this way with the head to tail, adding them, and that's the way I would first thing to do it. If you're very good, you could probably just spot that. Okay, so just in terms of marks, you're going to get a mark for the 2U and the half W, so that's worth a mark. and then you get a mark for your final answer. Okay, so they want you to put this information in a diagram. I think you'd be better off just writing ED is equal to 2U and DC is equal to half W, for example, or CD is minus half W. Just write it properly. I like drawing the diagram as well. Please write it properly as well. So yeah, a mark for knowing that, and then a mark for solving. Good stuff. Oh, here we go. Volumes, planets, right? Venus and Earth are two planets within our solar system. Fun factoid: so planets in the solar system. Way to remember it. I actually might not have time for this. My very educated mother just served us nice pizza. That's the way to remember. So it's Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Well, Pluto's not really a planet. But yeah, there we go. Fun factoid of the day. My very educated mother just served us a nice pizza. So, two planets. The volume of Venus. Okay, so Venus, that's 9.3 times 10 to the 11 cubic kilometers. So that's kilometers cubed. So we know that. This is 85% of Earth. Calculate the volume of Earth. Okay, so 85% of Earth. So we're saying that Earth is equal to what? Well, actually, maybe a better way to write that would be to say that Venus is equal to 85% of Earth. Okay, so Venus is equal to 0.85 V effectively. Okay, so we could do something like this, but I think the best way to do it is to do a formula. Yeah, I think what do we think the best way to say this? Yeah, I think I'm gonna settle with this. So we're running out of time. So we're saying that Venus is equal to 0.85 of Earth. So we know what Venus is. So we'll say that's 9.3 times 10 to the 11 is equal to 0.85 E. Handwriting does just get worse and worse and worse. Where do we write that? So yeah, so Venus is equal to 0.85 times Earth. So to get Earth on its own, we're going to do 9.3 times 10 to the 11 divided by 0.85. And that's going to give us Earth. Okay, so in the calculator, that's going to give us 1.094 to the power of 12 kilometers cubed is equal to Earth. Okay. So yeah, I was trying to think of a better way of, or an easier way of doing that. That's kind of what came to my head initially. But actually, I've just seen, and I've got enough time just to quickly go through. Yeah, maybe a much nicer way of doing it. We just put to one side. Okay. So this is 85% of the volume of Earth. Okay, so we know that 85% is equal to 9.3 times 10 to the 11. So that's doing it as a decimal. Okay, I've said 0.85 V is equal to V. I made a V equation up. But you could just say, well, 85% equals 9.3 times 10 to the 11. So find 1% by dividing by 85. So divide to this side by 85 as well. That's going to give you what 1% is. And then times by 100 to find what 100% is. We get the same answer, but that's actually possibly a much simpler way of doing it than my way, which is coming up with an equation. So yeah, 85% is equal to 9.3 times 10 to the 11. Find 1%, find 100%. Yeah, that's possibly simpler. Okay, so in terms of marks, just got enough time to go through this. You're going to get a mark for that first step. Marking scheme's got it this way, where you're getting a mark for your 1% and then for your final answer. Okay. Yeah, they actually don't quite have my method written down, but that's fine. Okay, so that was a find 1% go back to 100. That's probably an easier way of doing it. So this way I've got is interesting, but maybe actually you're best just doing this method.